All right. So here we go. Let's get started. Lesson 2. Lesson 2. We're going to see here that when we add radicals, they have to have like radicands. Just like when you add polynomials, x plus y, like let's do this one, 2x plus 3y. This is not like 5xy. Because they're not like terms. Do you agree with that? So just like with the polynomials and collecting like terms, for radicals, they have to have like radicands. So for example, 1 root 7 plus 1 root 7, that's 2 root 7s. That's okay. That's a smiley face. However, like root 3 plus root 2 is not root 5. You cannot just add the radicands like that. Okay? You just don't add the radicands. You can only add them if they're like terms. So what does it mean to be like terms with radicals? They have to have the same radicand, which is just the number inside the house. The little radical house, yeah. Okay, so this investigation is not necessary. We're just going to just jump. I think we can just jump right into class example 1. Okay, let's actually just do, let's do the bottom page. Bottom of the page. Yeah, we could do this page. Part C on the first page. Can you read letter I to me? 4 root 10 plus, yeah, I would say it like that. That's just a 1 root 10. Just like here, this is a 1x. Even though there's no 1 written. 1x plus 1x, 2x. 4 root 10s plus 1 root 10 altogether makes 5 root 10s. Okay. Well, could we do this with subtraction? Let's think about 5 root 3s, take away 2 root 3s. Altogether we have 3 root 3s. Good. Like this next one, is no different than 9x take away 4x take away 4x. 9x take away 4x is 5x. 5x take away 4x is 1x. It's just like this one would be 1 root 2. You can think of them as like analogies. They're just so similar in how we do these. So for part 4, like this is like terms. So maybe I'll underline the like terms just to indicate that they're different in terms of similarities. So let me just get you some space over here. So we have to put the root 6's together, and we have to put the root 5's together, but we have to keep them separate. So for example, how many root 6's do we have? 8 plus 2 makes 10. Good, you have 10 root 6's. And then how many root 5's do you have? Careful. Yeah, so you're combining. So this is worth revisiting. Think about, I always like to do this with physics. You guys all have taken probably Science 10, so this should be no problem. If you go 10 meters to the right and 8 meters to the left, where do you end up? 2 meters to the right. So it's like the pluses and the minuses, when you put them together, they work against each other, right? But what if you went like 5 meters left and then 6 meters left? Altogether you've gone, sorry, my bad. 5 meters left and then 6 meters left. Altogether you've gone 11 left. So that's like two negatives working together. Yeah, that's what's happening here. A -4 and a -4 are working together to become more negative. It's like you owe $4 and then you have to owe another $4. Altogether you owe 8. Where's my pen? In my hand. Okay. All right. Let's just do the one underneath while we're here. So 3 take away 5 take away 1. That's essentially what I'm visualizing. 3 take away 5 take away 1. -3 root a's. So, just because, why not? Let's just bring it up. Just so, sometimes I know mental math is not everybody's forte, so it's no issue just going, okay, 3, and I got a -5, and I got a -1. Okay, if I can't do this in my head, you know, at least I can use my technology to help me. Fair enough? So you can just add the coefficients without including the term. And one more here. 10x plus 5x is 15 root x's. Good. Any issues with that one? Okay, let's get on to the real stuff then. Okay. So next page, class example 1 and 2. This is the kind of stuff you're going to get on your quiz and on your exam. This is the level you have to be able to be aware of. So if you take a look at the top part, it says in order to add them, you need the same radicand and the same index. So for us, 95%, other than one question, is all squares. So if you were away yesterday, all questions on exam are power 2. Everything's squares, power 2. Everything's squares except for one question. Just one question will have cubes. Okay? So like while it says they have to have the same index, like for the most part, guys, you're always going to be working with squares and square roots. But there'll be one question with cubes and cube roots. Always with this pen. Okay. Okay. So 40 and 90, there's no chance I can add those. If you on your test go like this, then you're likely going to achieve a low mark because most of the exam is involving adding of radicals. Okay, so do not put square root 130. All right, so this is what we have to build on from yesterday. 40, you could break it down as square root 4 times square root 10. Now, if you were away yesterday, $40 in a root is also equal to root 8 and root 5. Why don't I use 8 times 5? Because they're not what? Not perfect squares. So when you go to simplify these radicals, you have to factor into perfect squares. What do you think 90 will break down into? Especially if we need the same radicand. Look, same radicand. You're going to be left with a root 10, right? So you're probably going to need a 10 in that one. What's that one going to be? Good. It's a root 9 times a root 10. So that was the stuff we did yesterday. Okay? Simplifying radicals using perfect square factors. Now root 4 becomes just 2 because it's perfect. And root 9 becomes 3 because it's perfect. And now you have 2 root 10s plus 3 root 10s all together makes 5 root 10s. So this is final answer here. 5 root 10s. And like that'll be in the written response. That style, for sure, absolutely. That's on the test. Just different numbers. And they'll be realistic numbers. I'm not going to make you search for stupid high numbers. Like They'll be reasonable, okay? Okay, so like 96, if you were away yesterday, I can show you a strategy for this. You just start finding the factors. So 96 divided by 4. Why did I choose 4? Because 4 is the perfect square. The other option is, the next option is 9. That one doesn't work because it doesn't divide nice. So what's the next option? Oh, 16 works. So which one should I use, 4 or 16? Use the bigger one, right? Use the bigger one. So we're going to use 16. How do you know it's definitely 16? Well, the other factor is 6, and there's no square that will divide 6. Okay? But if you look at the first one, like once you divide 4, you're left with 24. What is another factor of 24 that's a perfect square? 24 divides by 4 again. And that 4 make the 16. So like again, if you don't know your times tables too well, this can be a bit of a struggle, but definitely get used to the strategies that I show you because it will help. So this guy here is, what do we say, 16 and 6? And notice I put the perfect square first. Let me just keep this organized for you guys. I put the perfect square first, the 16, rather than the 6, because the number comes out nice in front. You see how square root 4 became 2? So I like to put the perfect square first. And be smart, you guys. You ended up with a root 6. So I wonder if 24 divides by 6. It does, right? What's the perfect square there for 24? 4 and 6, right? Root 4 times root 6. And the operation between them is subtraction. Now you simplify the perfect squares. 16 becomes 4, and 4 becomes 2. And then all together you have 4 take away 2, which is 2. Very nice. 4 root 6 take away 2 root 6 is just 2 root 6. Okay, also if you were away yesterday, and you're thinking these numbers, how can you get these numbers to show up on your calculator really easily? Go to the y equals. If you were here yesterday and Friday, you should know this already. Or Monday, I can't remember. Y equals, all you gotta do is hit this x button, and then hit this power 2 button. You get the x squared function, and then hit second graph, and then it's in the table. And you can see like 16 goes with 4, 25 goes with 5, 36, and so on forever. Okay? All right. Okay, so 75. What are you thinking about 75? I mean, it ends in a 5. So I'm thinking, you see this one here? 75 divided by 25, right? Yeah, good. Oh, where's my screen? Oh, and there's a 6 there. Just write it. Don't be afraid. 6. And then the 75 becomes root 25 and root 3. I'm going to zoom in on that so you can see it better. So what did I change? Did I change the 6 at all? Did I forget it? Did you leave your buddy, at the party? You just left. You just ghosted on your buddy. No, you bring your buddy along with you for the ride, right? This is what life's all about. You keep the 6 with you. 6 has to come down these lines as well. Okay, don't forget about your friends. Okay, 48. I wonder 48. So right now I'm going to pause the video, let you guys brainstorm. Yeah, good. You use 16 and 3. Excellent. Okay, so now, and do you like the arrows helping you? Do you like the arrows? Okay. So we have root 16 and root 3. And did I forget about the 3 in front? No, you bring it with you. Okay. And 27's not too bad. 27, most people know it has a factor of I mean, 27 is not going to divide by 4, right? It's not going to divide by 16. The only small enough value is 9. Okay, so we can change 27 to square root 9 and square root 3. Now I'm going to highlight for you all the perfect squares. Notice I put them in the front. So then this becomes 6 times 5. Why is it 5? Because 25 is buddies with 5. So what goes next to the 16? What would I change the 16 to? 4. And like, be organized like me. See how everything lines up? Everything lines up. How'd you get to school today? Did you guys fly in a plane? Yes. Did you take a train to the front steps of East Glen? Yes. Did you take a hoverboard? No, you probably drove in a car or a bus, and then you walked on a sidewalk. Those structures were built so that you could get here. Why don't you keep your math structured? Keep your math structured so that you're able to actually do it. Would you be able to get to East Glen if there's no roads? Yeah, you could get here. You could walk. If there was no sidewalk. Anyways, let's keep going. Okay, here we go. 6 times 5. 3 times 4. And 2 times 3. Now I'm just going to pause. Why is it okay for me to times the 6 and the 5 to make 30, but not times the 3? Why can't you times the 3 too? Yeah, it's in a square root. It's kind of like blocked off. It's like no entrance. You cannot merge the two. Because the 6 and the 5 make 30. 30 is rational. Whereas root 3 is irrational. You don't want to be putting the 30 into the 3. It doesn't make any sense. In fact, what really is going on is there is a bracket around this 3 with a power of 1/2. You might remember that from 10C. You guys remember the fractional exponents? So a radical is really an exponent with a fraction. So you can't multiply the 30 into the power. And if you remember BEDMAS, you have to do exponents first and then multiplication. So that's why you just keep them separate. And this is nice because they're all root 3s. So if they're all root 3s, you can combine like terms. And it's just 30 take away 12 plus 6. You could do that in your calculator if you wanted. 30 take away 12 was at 18. 18 and 6 makes 24. Are we okay with this? Kobe? Is that Kobe's number? Didn't he change it to 8 or something? Oh, so Kobe version 2. Did you guys like that question on the math exam about LeBron and Steven? Okay. 20? Hey guys, you with me? How you guys feel about these first two? Not too bad? I mean, they're pretty small numbers, 20 and 18. You should probably know those factors. Now 80 is a little bit of a dicey one because there's two options. So I'm just going to pause while you think about the two options for 80. And then 98 we actually saw yesterday. You remember 98? Look at this one. Do you see the 98 out of this one? Yeah. Yeah, 98's a common one because they love that 7s and it's hard to find. Anyways, 49 and 2, they're both radicals. So for this one, if I had a highlighter or just use your pencil, I would indicate to yourselves like which ones are going together. Just like some kind of marking system. I'm just using underlines here. It's probably not the best. But it's just, this is for the like terms. Like terms. So the 5s go together. What do we have here? 2 root 5. And this one is minus 4 root 5. And you have to take the sign with it. This term here with the circle around it is negative. It's a negative term. So when you combine it with this one, the positive and the negative, they work against each other. 2 take away 4, negative 2. Okay, now how about this one? What's that one going to be? Oh, and this, sorry, I'm getting a bit messy here. Let me change color so it's clear. The 2 blues got to go together. What do we got there? That's a positive 3 root 2 and positive 7 root 2. Altogether that makes 10 root 2. Okay. Okay, so the black ink is the root 5s, the blue ink is the root 2s. Collect like terms and just be aware of sign. Any term can only be plus or minus. Okay? There's not a third, there's no alien term like it's only plus or minus. So make sure you just check that box off when you're doing your homework. Pardon me? Divide? Why did I divide? Sorry, I don't understand your question. Maybe ask me later. Okay, let's try this one. Okay, 28's not too bad. 28's not too bad. What is it? Okay, one student's got it. Who else has got it? 28. 4 goes with? I want you guys actively doing this with me. Don't just watch and copy. That's not the point here. Let's just work out this first one. What's square root 4? So then altogether this term becomes good. Now I'm going to switch color. Let's try the next one. The 128, I actually have no clue about this one. So I'm going to actually just use my calculator. A 4 works because it ends in an 8. Is there a better choice? Yeah. When you divided it by 4, what did you get? Do it with me, please. 128 divided by 4. 32. I'm going to put this on the screen here to show you the brainstorming here. 128 divides by 4, and the result is 32. What other factor is inside 32? Yeah, you could divide by 16 again, and it's still a whole number. So you want to put 16 and 4 together. Use both of those. What's 16 times 4? So 64 is actually the best choice here. 64. Okay. So the minus 1/2 comes for the ride, and we use 64 and 2. Minus 1/2 comes for the ride. Simplify square root 64. What does square root 64 become? We just talked about that. That's 8. And then we have root 2. Now here we have, what is half of 8? If you weren't sure what to do with that, just put the 1/2 in your calculator with brackets and a division symbol, and then times it by 8. Like if it was a harder one. Like if it was a harder one, you could just go 1 divided by 2 in a bracket, and then times that by 8. Okay? Okay, so we got 4 root 2. Switch color one more time. Let's go red here. I wonder what this one's kind of obvious to me because it ends in that 5. Is it obvious that it's 25? And then is 7, sure. And then see how this one has the 7? So this one, these two are going together, and likely these two are going together. Okay, so we have a -2 comes for the ride, and 25 goes with 7. 2 comes for the ride, and 25 becomes 5. And 2 times 5 is 10. All right, switch color one more time. 63. If you know your times tables, this is an easy one. Two goes for the ride. You got a 9 and a 7. So actually, there's 3 of them that go together, and 1 is by himself. Root 9 is 3, so you have 2 times 3. Altogether, that makes 6 root 7. So oh, that is an ugly color. Let's try this one. Turn down the weight a bit. Okay, all the 7s go together. And notice I also highlighted the sign. The sign will help you. 6 of them, take away 10, plus a 6. Well, let's do the addition first. What's 6 and 6 make? And then you have to take off 10. So you have 2 root 7s. Take away 4 root 2s. That's his final answer. So one of those terms was unlike the other 3, so you just leave it alone. And notice it keeps the sign. This is a negative 4 root 2, so it keeps that sign. Those other 3 will merge and take whatever sign results. Oh my gosh, what is this? Oh, Olivia. Was that a quitter's attitude? You wearing your toque now? Oh my gosh. It is just Pythagoras' theorem. So how come you don't want to do it? You're just tired today? Alright. It is kind of easy. So we know in my experience, most students are very comfortable with Pythagorean theorem, especially if you're just solving for the hypotenuse. How can you identify the hypotenuse easily? It's opposite of the 90 degree. Very nice. So if the hypotenuse is unknown, you just have to take the squares of the other 2 sides and add them up. So what's the square for 6? Okay, so what's the square for 4? And what do we do with those 2 squares? You add them up and square root them. Gorgeous. So because that's going to equal the c squared, and then this will equal the c. So 36 and 16 makes what, 52? All right. Now that most students in grade 9 and grade 10, they're going to take that 52, they're going to throw it in here, and they're going to get a decimal, 7.211. If you're putting that on the test, you're likely going to get a poor mark. We do not want the decimals at this point in our lives in the 20 level math. Like, do not go to the decimal. Okay? I mean, unless it's a numeric response, but I really doubt. I'm in fact quite sure you won't have any decimals. So do not be going to decimals in this test. We simplify 52. I bet you can divide by 4. What's 52 divided by 4? 13? And 13's prime, so you can't do any more divisions out of that. So 4 is definitely the result. And then we finish this off as 2 square root 13. So that's the first hypotenuse. So now we do it again for the other hypotenuse. The 12 squared plus the 8 squared. I'm just going to use a different letter this time. Last one was C, so this one can be D. 12 squared is 144, and 8 squared is 64. To 208, thank you very much. And then to get D from D squared, we just have to square root this. And I'm trying 4. It, of course, works. What happens when you divide by 4? You get 52. We already did 52. What did 52 come out as? Another 4. So put the 4 and the 4 together for this one. Yeah. So let's just do 16 instead of the 2 4s separately. 208 divided by 16 is 13. So we get 4 root 13 after we simplify. And then they want to answer the question, which is probably just an addition or a subtraction. It says determine the total length to make both supports. So altogether 2 plus 4 is 6 root 13 is the be kind. All right, so 6 root 13 is the total. Just because if I didn't even read the question, I just kind of knew what they wanted. Determine the total length. So I need to find that length and then add them up to get a total. So it's a valid question. And I got this answer at the bottom here. Okay, so you have about 30 minutes to start the homework, and I'll give you a quiz today on this stuff.